Just because something is in the cloud doesn't always mean that it's safe and secure and that you don't play a role in keeping it that way. Those moving to the cloud need to understand cloud security best practices and how to implement them. Today's guest is Dr. Randall Magiera. Dr. Magiera is a cybersecurity professional with over 15 years of experience in security management, change management, risk analysis, intrusion prevention and detection systems, and vulnerability assessments. He has a Doctor of Science in cybersecurity, multiple advanced degrees in cybersecurity and technology, and certifications too numerous to list. I'm your host, Chris Parker, and this is the Easy Pray Podcast. Randall, thank you so much for coming on the Easy Pray Podcast today.
Thank you for having me.
So can you give me and the audience a little background about who you are and what you do?
Yeah, so I am an adjunct professor at Tulane School of Professional Advancement. I teach undergraduate and graduate level cybersecurity courses within the program. I've been in IT for about 15 to 20 years. I remember starting around 2000, dealing with Windows NT, Windows Server 2000, dating myself here. I picked up my doctorate in cybersecurity back in 2017 from Capital Technology University and have a decent number of wide range certifications. Of course, I have the Microsoft certifications, I have the ISC squared certifications, and all the typical stuff you would expect from a cybersecurity professional.
That's awesome. So what got you into cybersecurity?
So I remember working as an IT professional, doing desktop support, doing the help desk, helping people, looking at systems, patching systems, imaging systems. And I'm just like, wow, a lot of these companies, without mentioning who they are, of course, this is not a very secure way of doing it. So I looked more I got more interested in cybersecurity, realizing, hey, there's a gap and it's something that we need serious help with. So that's really what got me interested into it specifically. And now I'm starting to see with data information privacy, the same thing. As you probably have heard, at least I'm sure some of your audience members have heard not only of GDPR, of course, over in Europe, California CCPA, and the recently passed Virginia and Colorado Privacy Acts, which are pretty similar to CCPA. And then, of course, California themselves are updating CCPA with CRPA. So, yeah, it's a very interesting field to be in. Things are always changing, especially with cloud technology. When I started, the concept of cloud was just, no one would have thought of it, and it was, I think, around 15 years ago was really when AWS, I could be wrong about that time frame. So when AWS really started releasing their products along with Microsoft and Azure and Google Cloud. So, just to see the way technology is advancing, it's awesome. It's interesting, especially as a security professional. And it's going to be interesting to see where things go in the next 15 to 20 years as well. I'm really excited about that and really nervous at the same time.
Yeah, I think AWS has probably gotten a bit of the brunt of the cybersecurity negative references. Not so much that AWS has inherently done things wrong, or that they've intentionally done things wrong, but people using their platform haven't quite understood what they should be doing. Because I know, like in the news, over the years we've seen, there's an AWS instance was compromised. The AWS access wasn't set up correctly. So what should someone who's looking to go into the cloud, what should they be thinking about in terms of, how do I keep this from being my database that gets public?
It's a great question. And I like to back up. When we talk about the cloud, AWS, Azure, Google, these systems in themselves are essentially secure, if you will. These companies, even the smaller companies like DigitalOcean, they all go to great lengths to make sure that their product is secure, usable, what have you. Amazon Web Services, Microsoft Azure, Google Cloud, these are all great products. These companies work really hard to make sure their products are secure and usable. But here's the thing with cloud computing is they provide this platform for you to use, and it's up to you to use it. And if you use it wrong, that's on you as the customer. That's not on Azure. That's not on Amazon. That's not on Google. So there's this concept called the shared responsibility model. And you can easily look this up on a Google search. And each of the major cloud providers have these. And they say, hey, we're Amazon. This is what we're responsible for when you use our cloud service. And this is what you are responsible for when you use our cloud service. So when we talk about some of the data breaches that you've mentioned, such as, the S3 buckets being publicly exposed and data being leaked that way, that's on the customer. That's in their part of the shared responsibility model. So it's important that when you go to the cloud to not just get your credit card out and sign up for AWS, but to really take the time and research what you need to do to be secure when using that product. And there are also lots of commercial products out there. I'm not going to plug anyone in particular that can help you with this as well.
So as I say, has some of the issue been that either people, was this the shared responsibility models, was this buried in the terms and conditions, or is this something that anyone setting it up, it should have been abundantly clear, hey, this is public, anybody can see this. And even if you don't think anyone's going to figure out your this is my database.db, what I kind of wonder how much responsibility maybe a little bit more should rely on the platform providers to make sure that it doesn't accidentally become public.
It's a great question. And yeah, unfortunately, there's no real way to properly answer that. It is something that's been publicly available from day one, but then it becomes how much of a responsibility does Amazon and Microsoft and Google have to push that on their users? Now, I know for a fact these cloud companies nowadays, especially nowadays, do have these training events where they make people aware of, hey, these are the best practices when following AWS or when you're using Azure or when you're using Google. So it's a great question. At the end of the day, how much should the customer really be responsible for their product versus Amazon, educating them or not educating them? And one thing AWS now, and this isn't directly related to the shared responsibility model I just talked about, but they obviously, like Microsoft and like Google, they encourage everyone to push their application development to their cloud. And they have what's called the well-architected framework, which really is a set of best practices that Amazon will work with you to make sure that your environment is set up and optimized so your application can function as possible. You can push out updates, what have you. And part of that is, being secure. But it is really a great question. It is something that they make publicly available. And as I said before, they're working hard to make sure people are aware of this because at the end of the day, like you said, in the news, you're seeing all these breaches and people are associating that breach with Amazon, even if it wasn't directly their fault because of a customer not doing something properly.
So I kind of wonder if it's to me, I guess my mindset has always been, if I'm a network administrator and it's my network, it's easy to me. It's easier to think of my perimeter. This is the edge of my network. This is where my database is inside of my network. I know how to protect it there. Is some of the confusion that all of a sudden it's now it's on a different network. It's in a different platform. It's in a different environment that these administrators just aren't familiar with it? Or is it just kind of being lackadaisical about security?
I think it, quite frankly, could be both. But part of it is, I would say it's more people not being familiar with the technical aspects of going to the cloud. So, for example, in AWS, when you create a new virtual server, Microsoft Windows, by default, it's going to open it up to the public internet. It's going to give it. So in AWS, the basic thing, it's not necessarily a firewall. It's called security group. And that's what is basically a firewall where you add rules saying, hey, only this IP can access this virtual server on this port, what have you. But when you spin up that new virtual server, it does what's called a 0000.0 egress, or ingress, sorry, not egress, meaning that the whole world can access this server instead of locking it down to a specific IP. So if you're not familiar with the idea of a security group, how it relates to a firewall, really the technical aspects of it, that could be at least where some of the confusion is versus some people just not wanting to be secure, which is definitely another part of it as well. In my professional experience, I've seen those scenarios, obviously without naming which companies they were at. I've seen that kind of setup as well. So it can really go both ways. I think both of what you said are definitely part of it. And there are probably even more reasons behind behind this, what we see today, than what you said.
I think I've seen like instances where sometimes I think developers, and I'll throw myself in this category as well. Sometimes developers are lazy, and while we're testing things, we turn off security and we minimize security because we just want to make sure the darn thing is working, and then we can figure out, well, we'll ratchet down security later. Do you see that sort of thing happening where it's, well, we meant to come back and secure it after the fact, or maybe even got, access before the security was rolled in. But do you see people just kind of, as part of the development process, leaving security lax and then trying to tighten it up after the fact?
I mean, I can see that, especially with not all, but some startups. When you're following the agile software development methodology, the whole concept is to go, quick, let's move, let's, not sit back. We got to get our application out. We have to get our CI/CD pipeline up and running. We need to get our updates out. Unfortunately, sometimes things do get skipped, and it's not always, the developer being lazy. It's just, things happen, or a bug gets reported by a customer that's super high priority, and all of a sudden, oh yeah, I meant to do this, but it got moved to the next sprint or what have you. So that's definitely a reason. But because of the way everything is, it's just really complicated. But I can definitely see, software developers, not because they're lazy, but just because they're bombarded with things and they have competing priorities, that sometimes they forget to do that, especially from what I've seen in lower environments. So you've got your production environment that's super tight, locked down the way it needs to be. You've got your application in front of a CDN, a content delivery network, what have you. But then you have these lower environments that you're using for testing changes, what have you. And the security on them is a little more lackadaisical, obviously, than a production environment. That in itself, isn't a significant risk to the organization regarding, production data. But at the end of the day, if people are able to compromise those lower environments, they can insert their own code, or more commonly, they'll just throw malware on there and just turn them into crypto miners.
Yeah. I have a funny story to tell about crypto mining, and it's one of those. Sometimes things are totally out of your control. So I had gotten a support email from someone saying, "Hey, that's kind of rude of you. I visited whatismyipaddress.com. Why are you crypto mining in my browser? That's kind of shady business." And I'm like, I would never, I didn't do that. And okay, let me look at the code. There's nothing in my code I won't say the name of the crypto, the mining tool, because that's probably, I don't want to go that route. But there was no reference to the mining tool whatsoever in any of my code. So I'm like, no, this isn't, maybe this guy doesn't know what he's talking about. And I thought, well, okay, let me go into a browser and look at all the connectivity and watch all the things that are going on. And I searched for the cryptocurrency mining, and there it was. And I'm like, okay, so it's not on my servers. Like, where is this thing coming from? And so I, like every website owner, you've got these you've got not necessarily plugins, but you've got JavaScript that it's Google Analytics, it's a GDPR, CCPA privacy policy thing that pops up only in certain states, and you've got ads and all these little things partners that do different things. And ultimately was one of my partners downstream to them, something, some repository that they were using was compromised, and it rolled that cryptocurrency mining script up into my website. So it's like, yeah, sometimes it's multiple people removed before these things happen, and you don't know about it.
Yeah, in fact, it's great that you mentioned that. Like I said, we don't want to go too far down that, but just a couple of weeks ago, a popular JavaScript library, the NPM package, was basically, okay, you're familiar with that. Yeah. It was.
Let's talk about it, because it's a little beyond my understanding, but let's talk about that. There was a fairly popular repository that was compromised. What was it? Where is it used? And what happened?
So it's the NPM package. It's part of a JavaScript library. And basically, and this is not the first time this type of thing has happened, but the malicious actors I don't use the word hackers because it offends certain people in the industry when referring to hackers as bad people. So I just say malicious actors. The malicious actors, they basically insert malicious code, primarily to mine primarily crypto mining malware, but password stealing malware. And basically, if no one's checking the source code, no one's checking the package, software developers all over the country, all over the world are using this popular package. So they're putting this into their application, rolling out to production, and these malicious actors got a heck of a lot of cryptocurrency getting mined for them. This is not that uncommon. It's happened more than once on open source packages and even closed source packages. So the whole SolarWinds thing, they basically did the same thing. They were able to, for lack of a better phrase, infiltrate an update, insert their malware into an update, and got that update spread everywhere that runs SolarWinds.
I think they call it supply chain hacking, so to speak.
Mm-hmm. Absolutely. So yeah, this is not uncommon. In fact, it's going to become even more common. That's why, especially as a software developer, and I know we want to talk about cloud security, but, software developers, when they're looking at these packages, it's, just make sure you're double checking each package that you download, which, can be hard because, some production applications use dozens, if not more, of open source packages to properly function. But yeah, it's very interesting to see the way that malicious actors are now injecting source code in what they're doing.
Yeah, it's devastatingly clever at times. That it's becoming more and more complicated for the everyday person to kind of know what is safe, what isn't safe, what should I be doing, what shouldn't I be doing.
Oh yeah, and I mean, especially crypto traders. I'm sure you've read about it, but there's malware out there that does nothing other than change a wallet address to the people behind the malware. So you're, making a trade and then you're copying and pasting that wallet address in, and next thing you know, it didn't go to where you wanted it to because you have this malware on your system sending it to the wrong wallet. And, as you know, when you deal with crypto, once you click send, it's gone. It's like Venmo. Once you press that button, that money's gone. That cryptocurrency's gone. Sorry.
It just gives me the cryptocurrency gives me the heebie-jeebies, not because of the technology, but by how it is so frequently used for nefarious purposes in terms of separating people from it.
Oh, yeah. The one interesting thing, I'm sure you remember the Colonial Pipeline Act. Mm-hmm. It happened. So, as I said before, I'm in Raleigh, North Carolina, so I felt the brunt of it, skyrocketed gas prices, gas shortages everywhere, the people taking 15, buckets with them to fill them up because they think it's going to be, gas is going to be gone forever, whatever the reasoning behind it was. But the reason I bring it up is because the FBI, and this is the first time I'm actually familiar with this actually happening, the FBI was actually able to recover some of the Bitcoin used for the payment to the actors behind the Colonial Pipeline Act. It wasn't a lot, but they were able to recover some, which, typically goes against the way cryptocurrency works. So I thought that was really interesting.
Yeah, I've been reading more and more cases where I shouldn't say the cryptocurrency transactions are being reversed, but somehow they're able to get some of the money back after the fact. So it's kind of interesting. Like I have not delved in deep enough to understand the mechanics of why, in certain circumstances, they're able to get money back. But it's not what anyone should assume when it comes to cryptocurrency. Oh,
absolutely, especially when actually paying a ransom for a ransomware attack as well. From my understanding with the Colonial Pipeline, they were actually able to, they watched the Bitcoin being transferred from wallet to wallet to wallet to wallet because, that's the way it works with malicious actors. But I guess they were actually able to seize a couple of the wallets, which is actually how they're able to recover some of the cryptocurrency in that particular case.
That makes sense. They are able to grab it before it got into a different account.
Right.
All that kind of fun stuff. So let's get back to cloud security. And I think it's funny because I think of the cloud, and I had a sticker once that cloud it's just somebody else's computer, which it really is. And there's some like really really amazing advantages to the cloud. There's pros and cons. I'm a huge fan of CDNs, which are content delivery networks. If you're a business or a website operator and you have users from all over the world, CDN puts those assets, in data centers down the street from your visitors, as opposed to halfway around the world. I always joke when people visit my site, it's really nice that if they want to get a picture of me, they can, and they're in Singapore, they're getting it off a server in Singapore, as opposed to that request going all the way to the United States, going to my co-location facility, and then going all the way back halfway around the world. It's really neat the way that stuff works. And I start wondering if we're going to start seeing not necessarily CDNs being compromised, but CDNs being leveraged in malware attacks and whatnot.
Yeah, I don't doubt that will happen at some point. As you know, CDNs, they host static content. There's nothing to stop a malicious actor who's able to gain access into someone's S3 bucket or wherever they store that static content to, modify it, whether it's a picture, whether it's, a script or what have you, and put their code in it. And then that gets served up to the CDN, who serves it up to users worldwide. I think if it hasn't happened, I haven't read of it happening yet. I think it's only a matter of time before it does.
Yeah. And I suppose the cloud security actually works in reverse also in some respect in protecting. I know platforms, let's say I'm more familiar with Cloudflare. Cloudflare actually does have processes in place to mitigate SQL injection, kind of very common attacks on websites. So you almost can see kind of cloud security as a service, so to speak, coming to fruition, as well as protecting cloud assets from the public.
Oh, yeah, absolutely. Some of the features at Amazon's WAF, Web Application Firewall, they are, like you said, they're protect. They see SQL injections. They see requests from known bad IP addresses. They'll alert you, regardless of what your SIM is. You can use CloudTrail, which is their product, or you can export CloudTrail alerts to your own SIM, regardless of what you're using. But yeah, absolutely, they do that, and they make those features available to their customers, usually at a premium, of course, but they make them available so that they can protect their application. It's just one less thing that they have to worry about. They obviously still have to ensure that their databases are properly defined and that they can't be hit by a SQL injection to begin with, but that extra layer of protection is always nice.
Yep. Kind of what do you see as the kind of the future risks of cloud platforms? I mean, obviously, I think of things like, China wants to make sure that, okay, if you're a cloud provider, data for users in China is stored on servers in China where we have access to it. What do you kind of see as the future of the cloud and cloud security? And are we going to get to the point where we don't have 2 terabytes of storage on our phone and it's just going to be nothing is stored locally?
I mean, I think that ideally is the goal, to get everything up in the cloud, if you will. But yeah, with the laws, regulations that we're seeing, especially around Europe, you mentioned China wanting data from Chinese users stored in Chinese servers. So if you're using Alibaba, which is the most popular cloud provider out in China, you'd want to use that. Or if you're in Europe, you have to worry about GDPR. If you're, selling to EU citizens, you have to use the AWS region to store their data. But you combine that with a CDN, it makes it a lot more reasonable to go to a German website. But the future cloud security is going to be really interesting, because you have to remember a majority of malicious actors, they are just motivated by money. They're financially motivated. That's the number one most common reason malicious actors are hacking. Most of them aren't hacktivists. They don't care about who the president is or what they did. They just want to get paid. So they're going to use the cloud in creative ways to get paid. And I remember reading one thing recently, an article where some malicious hackers, they didn't go into great details. I wish they did. They used AI to mimic the voice of a CEO, and then use that to call the CFO to get a wire transfer going or what have you. They scammed the company using the CEO's voice, using AI. So those are going to be things like that are going to be more common. And it's going to be interesting to see how the malicious actors use the cloud, as a means to their end, whether they're hacking it directly or leveraging the cloud to do what they want to do.
I mean, I guess that is another thing that could happen is if you have, AWS has Elastic Computing, where you can spin up hundreds or thousands of processes to do your AI work for you. Mm-hmm. And then, your bad actor doesn't have to have all that compute power themselves. They just spin up instances, probably ones that they've gained from other people, in other people's accounts to do their dirty work for them.
Yeah, I mean, another thing that malicious actors probably do more often than we realize, pretty easy, is get someone's credit card information, open up an AWS account, spin up a bunch of EC2 instances, the virtual servers, install crypto mining on it, and just mine away. And then when the bill comes at the end of the month, the person cancels their card. The servers get shut down, but all the cryptocurrency that was mined, the malicious actors get to keep. It's not like Amazon can take it out of the wallet or anything.
Yeah.
So there's just, malicious actors, they're just going to use the cloud just like all other forms of technology to, as a means to their end. So it's going to be interesting to see how creative they get. We've seen some really cool stuff. And I think, in my personal opinion, what I think we're going to see more of are deepfakes. Yeah. As the technology advances, I think we're going to see more deepfakes. I don't really consider mimicking the CEO's voice in the thing I mentioned as a deepfake, but I think we'll start seeing more of that to used by malicious actors because using AWS, they have the technology to create whatever they want and use it however they want.
Yeah, to me, the most worrying is if you can do kind of real-time deepfakes.
Right.
Is once something like that can happen. It's one thing if a bunch of guys in their offices with a bunch of high-end computers and an actor look-alike, and can create their fake Tom Cruise, running around the set. Yeah, it took them hundreds of hours. I don't know. It took them quite a few hours to create that video and lots of training, but it's not real time. When people are talking about like romance scams and whatnot, the common advice is, look, if they're not gonna do a FaceTime with you, if they're not gonna Skype, they're not gonna do a Zoom with you, and show a live video of them actually answering questions, then they're obviously a scammer. If they won't show up on video, then they're a scammer. But once you get deep fakes that are real time, and the scammer can sit there in front of the computer and it changes their face to match whoever it is, and now that they can talk at the same time and not have to make excuses about I'm halfway around the world, my internet connection's bad, let me just turn off the camera, or my camera's not working. And I do kind of wonder if that will be sourced through kind of these cloud computing platforms.
Yeah, I mean, as I said before, these platforms, they provide a virtually unlimited amount of compute power to whoever needs it. So I can definitely see that happening. And then that's something that AWS, Microsoft, Google, anybody else who comes up through the ranks, it's something they're going to have to be cognizant of and proactively work on themselves as well. So, as I said at the beginning, I'm really interested to see where everything goes in 15, 20 years. And we're definitely talking about what can and likely will happen probably within the next 5 to 10 years. So,
that's the scary thing. Do you think, let's not just pick on Amazon here, but do you think Microsoft Azure and Google Cloud that there's going to have to be a kind of step up and I don't want to say like taking responsibility, but more ownership, so to speak, by the platform providers in enforcing security and watching out for things that are misbehaving on their platforms, as opposed to, oh yeah, we just saw 40 instances spin up that are doing Bitcoin mining. Let's poke at that and figure out if that's a stolen credit card, or, at what point did they have some responsibility in this? I mean, obviously, someone, if Microsoft, someone burns a few hundred kilowatts of electricity doing cryptocurrency mining, it's totally trivial to their business model. But at some point, it becomes problematic, and do they have to take a bigger role in preventing this sort of thing from happening on their platforms?
It's a great question. It's something that I like to say people smarter than me should answer. One thing I will say, I know they do some stuff. So if you want a great example of some of the lengths that AWS and them go to, protect their stuff. If you have a Git repo, go throw some AWS credentials in one of your source files. You'll actually be pinged pretty quickly that by AWS saying, hey, we found these credentials in your repo. So, please do something about that, because you probably don't want to do that.
That's good. So they're actively scanning to make sure that credentials haven't been exposed, and if they are, they're proactively alerting you to it.
Yeah. So they do some stuff, but at the end of the day, from a legal perspective, you sign the contract with Azure, you sign the contract with Google. If you mess up, unfortunately, it's on you. It's not on them. I dealt with a company, without naming names, but I dealt with a company who had a third-party company delete their production data, and they were using one of the major cloud providers. They spent a week and a half working with the cloud provider, the third-party company that is, to try and record the data, because for whatever reason, they also deleted the data out of the backups, which I don't really want to go into right now, but they spent a week and a half going back and forth with the cloud provider saying, hey, how can we recover this data? And the cloud provider basically said, per the terms and conditions, once you delete the data, it's on you. Another great example of this is code spaces. Do you remember code spaces? Mm-hmm. So just for the listeners who have not heard of it, Code Spaces is a now defunct company. And this was, I believe, a decade ago, but Code Spaces, they're trying to compete with GitHub. So they were a repo for all your source code. And what happened was, they were hosted on AWS, just like almost every company nowadays. And a malicious actor was able to gain access into their system. So they sent an email to the CEO or one in the security team, what have you, and said, hey, listen, I have access into your environment. If you don't pay me off, I'm just going to basically delete everything. So, when they got the email, of course, they didn't pay them. They just went and changed their logins thinking everything was good. But what happened was the malicious actor had created another account that apparently they missed. And the malicious actor then logged in, deleted most of their production environment, deleted all their backups, shutting them down. And they worked and they contacted AWS. They said, listen, this is a malicious actor. This wasn't something we accidentally did. Can you help us? And unfortunately, Amazon said, no, we can't. We don't retain that data. Once it's deleted, whether it's done by you or somebody else, it's deleted and it's gone forever. So it's a really complicated scenario. I'll be interested to see, what, like I said, people smarter than me think of how these scenarios can change, or what AWS and them can do or should do to help potentially cut off future security incidents. They do some stuff today. Like I said, the scanning GitHub and scanning source code's great example. And they do, I'm sure, a lot more they don't tell you about. Yeah. But the question is, at what point is enough? And hey, you did something stupid. I'm sorry, but it's on you.
I mean, I think it's a really good point to mention that, like, I hadn't actively thought about it, that if stuff is deleted out of a cloud instance, it's gone. It's not like I have a physical server in a data center somewhere, and sure, I can grab that out and take it to a drive recovery place, and they can do their best to recover some data from it. These cloud platforms probably have to go to some fairly extensive lengths to make sure that data can't be like, if someone gets a hold of one of the drives from their data center, that it actually can't be recovered. And so that brings up interesting issues of backup and having your backup in an instance or in a position where it can be disconnected and should remain disconnected when you're not actively backing up.
Oh yeah, absolutely. So I mean, I'm sure it's in their SOC report. Obviously, you can't discuss their public SOC report or their private SOC report, but I'm sure they use full disk encryption, have a number of controls in place to ensure that their disks are encrypted. So if someone somehow manages to sneak a disk out and walk away with it, that they can't recover anything off it. But with the number of services that are out there, like not only are there regular backups, but they're Glacier, which is I don't want to call it cold storage, but it kind of is cold storage because it's technically sitting on a disk on a shelf, and when you want it, you have to wait a half hour for the automated arm to go grab the disk and plug it in and get your data spun back up. But it's interesting. Another thing to mention is, the way a lot of these cloud providers work is, it depends the service, but just because you have something somewhere, like if you have an EC2 instance, for example, there's no guarantee that it's even backed up to begin with by default. Mm-hmm. So I'm going to go with AWS because it's the one I know the best. AWS's S3, their simple storage service, that's actually backed up in multiple locations. So the way AWS works is you have these regions, right? You have US East, you have West, you have Frankfurt, and then you have what are called availability zones. Now, the availability zone in itself is a data center. The region is simply a location. Mm-hmm. So when you spin up that EC2 instance, that server, unless you pay that extra money for it to be in a different AZ or multi-AZ, it's just in that one availability zone. And if something happens to that availability zone, your environment's gone, sorry, especially if the stuff's not backed up. So the S3 service by default, it's in multiple AZs by default, but the EC2 instance isn't. And none of these major cloud providers have a track history of losing data and losing AZs, but there are scenarios where it has happened in the past. So it's one other thing for people to think about when using the cloud. And it's actually, I personally like that it's an extra feature because it gets people to think about it. Mm-hmm. Working in IT well before the cloud, the companies I worked at, we had a data center. And if something happened to that data center, we're kind of, we're messed up, sorry, production's down, what have you. And then, talking with management, it's been kind of hard to get that colo as a backup or a warm DR or cold DR or what have you, or even getting your data off site. Whereas with cloud, it's just an extra charge to do multi-AZ. And you just got to convince management that like, hey, yeah, this is unlikely to happen, but for an extra $50 a month or, whatever the charge is, we just click this button. And if this area does go down, we're not losing everything and we can be back up pretty quickly. So that's one of the things I do like about the cloud computing. It builds in DR. It makes it a heck of a lot simpler for environments than in your traditional data center where you literally had to have a colo or reciprocal agreement with a different company, or in some cases, literally build your own data center halfway across the county, the state, the country, whatever your DR requirements were.
And by DR, you mean disaster recovery, correct?
Yes, sorry, disaster recovery, absolutely.
We easily get into lingo when we talk tech. Yeah, no, there was a company that I had done business with that they built their own co-location facility in their own building, really nice facility, and they had massive storage requirements. But like the hassle for them was to build the disaster recovery on the other, like, okay, how do we do the disaster recovery on the other side of the country such that if something happens to our building, we still have our data, it's still somewhere else, it's still safe, not just, and I think this is actually true of most people's view of data backup, is most people think of, well, if I've got that hard drive and it's sitting in my closet, I've got a backup. My opinion would be, well, if your house burns down, it's not really a backup. It's what's the story? 3 copies, 2 locations. Well, I don't know, multiple formats, multiple locations, in the cloud, physical, other sides of the country.
Other sides of the world, yeah.
Other sides of the world. But that,
yeah.
I mean, that truly is one of the amazing things about cloud platforms is when they're operated properly, something goes down, it morphs around it. The backups the backup instances happen transparently. Maybe with Facebook's outage recently, that's the scenario when the cloud does not perform well.
When you tie, it's a risk when you tie everything to a single system, and when that single system doesn't work, and you can't get into your data center to fix that system because the door lock is tied to that system, which doesn't work, and you have it fail safe, fail secure, not fail open. Yeah, it becomes a problem. But yeah, like you said, it's one of the nice things about the cloud is if you can sit down with your company's management and hammer out what disaster recovery requirements are, which is a challenge for a lot of IT professionals. I don't need to tell probably a lot of your listeners are probably sitting there thinking, yeah, good luck having that conversation with my boss. But, hammering those out and actually figuring out what your company wants, needs, and willing to pay for. Yeah, with the cloud, you can do that pretty easily.
Yeah, and it's when you know what you want to do, it can be fairly simple. And like you said, it's just a feature switch. Enable this, and this is where I want it to go. Although I guess I would always say, always test and try to figure out how to flip that switch yourself. I can't tell you how many people I've talked to who thought they were doing backups of whatever, and when something failed, they went to the backup and it was empty, or the process had failed 6 months ago and never recovered. The tapes were bad because they'd never been replaced after, being swapped out every day for 16 years. Always test the backup plans. Always test the security. Make sure it's doing what you think it's doing.
Yes, and always test your DR. That's a common, even using a cloud provider for backups for your disaster recovery. It's still a best practice, still requirement for some compliance to, test your backup, test your DR, and make sure you actually have something that functions versus saying you've been paying for this service and it doesn't actually function when you actually did need it.
Yeah, that's the time you don't want to find out that it's not working.
Right, exactly.
So let's wrap up here. If people want to find out more about what you do, about your classes, where can they find that?
Absolutely. So I am an adjunct professor at Tulane School of Professional Advancement. I have undergraduate and graduate classes. Just feel free to Google Tulane SOPA, School of Professional Advancement. And, you can find anything there. You can always reach out to me directly if you have more questions. I am on LinkedIn. Just search Randy Magiera. And I'm always happy to chat about, shoot the breeze about whatever topics you guys like. So, but yeah, to learn more, just Google Tulane SOPA. We have a great program, lots of very interesting classes. I teach the cloud security class, and I've got some really great examples of real life breaches that I incorporate into the class material. So yeah, it's good stuff, and it's a great program, and obviously a great school. It's Tulane University. So
awesome.
Absolutely.
We will make sure to link to both your LinkedIn profile and to your page on Tulane. All right. Thank you very much. Have a great day.
Yeah, thank you. You too.
Thank you for listening to this episode of the Easy Pray podcast. Notes and a transcript of this episode with Dr. Randall Magiera can be found at easypray.com/97.